I'm delighted to speak with you today about how Tom Sawyer Software can help you to build and work with knowledge graphs to get more value from your business data. Graphs might be the hot new topic in IT, but Tom Sawyer Software has been delivering graph-based solutions for industry for more than 30 years. So if graph technology has been around for such a long time, why is it that knowledge graphs are suddenly the hot topic? With the explosion of data that we're able to collect and the expectation for speed and flexibility, the demand for graph technology has been expanding. In the past 20 years, a large number of commercial solutions for graph data storage and analysis and visualization have become more mature and mainstream, making graph data solutions more widely available and affordable. Graph data underpins tools that you use every day, including Google, Facebook, Amazon, and Netflix, among many others. A key driver for these tools to move to graph technology is the rise in importance of connections over number crunching. Another significant hurdle we experienced in those 20 years and before was that populating a knowledge graph with good information could be very difficult. Our legacy data sources didn't necessarily contain all the context we needed in order to build a good knowledge graph. The advent of new methods of machine learning that help to collectively classify incoming data has made many aspects of working with knowledge graphs more practical than ever before. And finally, there were few tools to visualize knowledge graphs effectively. Even if you had a good knowledge graph to work with, the solutions to automatically generate visualizations that really served your end users were limited. In engineering and process control, the process of visualizing the knowledge graph largely stayed manual. Pictures are worth 1,000 words, but maybe not if they take you 1,000 hours to build. And they're only useful when they match up with what your user needs. Think about the number of times you've used PowerPoint boxes and arrows to communicate effectively. What if your data was smart enough to draw its own boxes and arrows? That's what a knowledge graph is about. That's the problem I faced as a software innovator and developer, and that's what drew me to work with Tom Sawyer Software. Graphs are powerful, both for analytics and end user interaction, because they represent the world in the same way that we think about the world, as important ideas with special connections to other important ideas. Your mind is full of very rich context about the things you care about. In the business world, it's rare for all the context information you have to be presented in one place. That's the problem that knowledge graphs are built to address. Knowledge graphs help you to seamlessly shift contexts from financial to manufacturing, for example, or to add new contexts like risk management or maintenance when those become available to you. Tom Sawyer Perspectives helps you every step of the way, from designing the knowledge graph you need to building the graph analytics and the visualizations that make a difference for your users or customers. Even the most simple knowledge graph, populated with good data, can be very powerful. And here we have a very simple knowledge graph schema. We have devices and connections, and the devices have a location. But by adding a few domain rules that say how our user want to view these devices that are connected to each other, we're able to build a really compelling domain-specific visualization that our end users can make sense of instantly. This is the leap to support people with very specific knowledge graphs, possibly in engineering. In this case, this is the heating and ventilation domain, and automate the delivery of those graphs and visualizations and interactions with this information so that people can make better use of the data. Let's cover a few basics. What really is a knowledge graph? Like our brains, knowledge graphs take facts and link them meaningfully with related physical or logical concepts that matter. The knowledge graph includes the semantics, the meaning of the connected facts. The semantics of a knowledge graph is like the schema in a database. A knowledge graph has an underlying schema that describes what the objects and connections in the graph mean. And then the knowledge graph itself, the part that your users interact with, are the real instances of things that match that schema. Most business intelligence applications that you're familiar with today have focused on crunching numbers, aggregating data over time or location, because they were largely based on financial business systems. But that can leave you wondering what is really happening behind the numbers. What do those numbers mean? And why are the numbers the way they are? By pairing charts that include financial data or other numeric data with visual layouts that help you get down to specific individuals behind those numbers, you can really bring more power to your visualizations and your business interactions and your ability to problem solve. Because sometimes numbers aren't the best way to get the answer to how or why in a complex system. For developers, knowledge graphs are an important tool for addressing the gap between legacy software and last generation databases and the problems you need to solve today. For end users, knowledge graphs can provide more natural interactions with information, unconstrained by legacy database structures and silos. There are a number of ways that knowledge graphs might apply to different industries and different sorts of problems. If you visit our website, you can explore these for yourself, and you can access many of the sample applications that are presented here and interact with them and learn a little bit about them. In the area of finance, fraud detection is a big deal. And this is an example illustration that is showing that there are a number of individuals here that are relating to the same phone numbers and the same identifiers. Now, that might be a number of individuals in the same family, but it might also be somebody trying to defraud a system. Similarly, there are graphs, knowledge graphs that help you to manage operations, whether that's understanding what your reporting structures are, especially in a matrixed organization, or perhaps what policies and procedures people need to be aware of and how they work. It's also very useful in production systems where you need to trace the path of materials or processes from one place to another or from one working component to another, much like the HVAC example I showed. And another example are supply chains. Let's look at the supply chain example in a little bit more detail. Here's an example application. This is another one that you can access yourself from our website. And this illustrates an example supply chain application. In this case, we have a number of products here in our tree on the left, and I've selected this pen set that is produced in North America. And this is illustrating the entire supply chain that relates to the delivery of this pen set. By illustrating the supply chain in this manner, we can instantly see where the initial bottleneck is that's preventing timely delivery of our product. If we were only looking, for example, at the entry in the table down here, it would be very difficult for us to understand all the dependencies and the other things that might be impacted by this problem somewhere in the middle of our manufacturing stream. We offer many tools to let you build the application you need with your knowledge graph and give your end users the options to not just visualize the data, but to take the right action on that data. Here we're showing a few examples of how we might look at other aspects of the supply chain, but we might also be able to do things like understand how to repair a problem that's happening somewhere in our chain, or maybe work around it by looking for an alternative supplier for whatever this item happens to be. Knowledge graphs like this make upstream and downstream dependencies crystal clear. There's another way to view the information as well. With any knowledge graph, there are a number of different contexts that might matter to you. In the first view, we were looking at the details of how a product is being manufactured and what are the components going into the product. But in this view, we can take a look at what all of the products are, where all the products are produced, and what our dependencies are in terms of how much shipping we're doing to get this product out the door. And maybe we want to take a look at the complexity of this particular production chain and possibly move some of our production to another location to reduce the complexity. Let's take a few moments to discuss the technology behind knowledge graphs. Many purists will tell you that a knowledge graph is based on the WC3 semantic technology stack, which also uses the resource description framework, or RDF, and often begins with a formal ontology. While I'm a big fan of ontologies, they aren't the only way to implement a practical and useful knowledge graph. The ontology is the item you see on the right. In an ontology, all nodes and all properties are nodes. So all of the things you care about and all the properties about those things you care about are represented using exactly the same structure called a triple. Sam is married to Liz. Alice was born on this date. Alice resides in this place. It's a very systematically consistent model. It's also very verbose. On the left, we have the example of a labeled property graph. And labeled property graphs are the most common implementation of property graphs that are knowledge graphs that you will find today. They're more popular because they more closely represent what our software developers are used to in terms of object-oriented programming. In a property graph database, you have entities and edges, and you have properties that belong to either entities or edges. And this makes programming against them a lot easier. Now, structurally, the approaches are very different, but your end users probably aren't going to be able to tell the difference between these two approaches when you present them with good information. However, your developers will have a very different working experience with these two underlying technologies. As with any other decision about technology, knowing your long-term and short-term goals is critical to making the best choices. If wide-scale machine readability and interoperability is your goal, then you might want to consider the WC3 semantic stack as your starting place, because it's driven by very well-defined and well-maintained standards, not just for describing data, but also interchanging that data and querying against that data. The entire technology stack is a maintained standard. It's also the case that you might want to use both tools to satisfy your different needs. Ontologies provide very precise classification, but that doesn't necessarily make them the best choice for the end delivery of information to your customer. Labeled property graphs can be a little bit more practical for your final use case with your end users. It doesn't mean you have to make an either-or choice. You can work with both of these technologies together. One thing that Tom Sawyer Software can do for your development team is to smooth out the differences. Tom Sawyer Perspectives works with all of these native graph technologies, both those that rely on the semantic stack as well as labeled property graphs, and a huge host of legacy data solutions, including relational databases and flat text files and JSON interfaces, among others. The way Tom Sawyer Software does this is through our Perspectives platform. The Perspectives runtime platform allows you to identify the data sources you want to import. You saw that earlier when I was showing the integrators in my project. Once you've identified those sources, you can federate your data in a schema. And we also briefly looked at the schema editor earlier. And once that data has been identified and you've defined how you want your knowledge graph to work for you, then you can use additional tools to further process that information, to make inferences, or to further alter that information and add information or calculate new information that will augment that knowledge graph. And finally, at the presentation layer, you have a whole host of other choices you can make about how to present that information to your end users, what types of visualizations will work best for your domain or your specific problem, and get that to your users simply and easily, and also with a great deal of flexibility. Now, we're going to take a look at a specific example. We'll look at some of those pieces of Tom Sawyer Perspectives that I mentioned earlier. This is a project that combines music data and movie data so that we can see all of that data at once. If you consider the experience you have online, if you, for example, run a query to learn more about Dolly Parton, you'll probably find her in the movie database. And in the movie database, it'll tell you all about the movies she's been in, but it might not actually tell you that she wrote the song 9 to 5 that appears in that movie. In the music database, on the other hand, Dolly's entire musical career may be present, all the songs she's written or sung, but it won't know anything about the fact that the song she wrote was part of a movie. So how can we see all that information at once? In this case, we have 3 data sources that we're bringing in. The first one in the list, because this is alphabet, because the way this is ordered, is an Excel data set that I created because I had an incomplete music set in this Tinkerpop database. So I added some information myself that fills out Dolly's music career a little bit. I also have a connection to a Tinkerpop-based database, which contains a subset of the entire MusicBrainz library. If you aren't familiar with the MusicBrainz library, this is a really excellent open source database that you can look at yourself. It is quite extensive. And then the third data source we have is this Neo4j sample data set, which we call Cineas, and that contains information about movies. And you can see the disjoint schemas here. This artist and song database, this is the music data source. And this schema was imported directly from this graph data source. It hasn't been altered. It is natively a graph. And here we have artists and songs as vertex entities or elements, and they're connected by these relationships or edges. Songs can be written by artists, and songs can also be sung by specific artists. And then down here, we have a completely independent schema. This is the movie schema that came in from the Neo4j database. And in this case, we have persons who can direct movies and or act in movies. So let's see what happens when we look at this application running. So we did that we have Dolly Parton, the actor, and we also know that we have Dolly Parton, the singer. And in this data set, we can see here that we have both movies and music connected to Dolly Parton. Dolly doesn't look like the other people in this diagram. Let's take a look at what we see when we expand this node. Aha, we really have two Dolly Partons. Now, in your knowledge graph, you might not want to be this transparent. You might not want people to know that you're getting data from two places. That's okay. There's also a very good use case for giving this level of detail, especially if you want people to help you crowdsource better information. Because if they know where the data came from, then they'll have a better chance of telling you whether it's right or not. Let's take another view of this data. Again, this is a full transparency kind of display of the information that you're using to populate your knowledge graph. Here we see across the top the source of the data that we're including in our chart. And here you see an alternative way to illustrate that this Dolly Parton from Cineasts is the same as this Dolly Parton from Music Brains. You could use an illustration like this to help your end user say, oh, this data is bad, and they'll know who to report it to or who might own this data source that it's part of. They might also say, you're making the wrong assumptions. These really aren't the same people. Luckily, I chose a case that is really easy. There's only one Dolly Parton. Now, if you don't want a data visualization that is that transparent, you can just as easily produce a visualization that says, no, there's one knowledge graph and people don't need to know that level of detail, and I'm just going to present the information. This one is also showing a different sort of template. The other thing that Tom Sawyer Software can do for you is give you many different options to visualize a knowledge graph. We looked at one earlier that was very structured for a specific domain problem. Let me just refresh this. We can also use different layouts. And by using a different layout, it tends to highlight different parts of the information that you care about. And layouts can actually deliver new and fresh information to you about how closely someone collaborates with someone else, about perhaps how things are associated hierarchically. We also offer timeline views. So one of the next things I'd really like to do is put all of Dolly Parton's music history on a timeline and take a look at who she collaborated with and when, and maybe how those music careers developed together. I think it could be very interesting. So you probably don't care much about Dolly Parton. You've got your own business problems to solve. So how is it that you would get started on your own knowledge graph journey? Getting started with a knowledge graph is not a lot different than getting started with any other software development. It's really critical to start small and get buy-in. Make sure you pick a problem your business really needs solved, and you don't try to model everything at once. You can end up in a thrashing over the model and trying to agree on what the model should look like before you even try to use the model. And that can mean death to your project. The two biggest failure modes in my experience are not having that buy-in you need and trying to boil the ocean. Another point is to try not to start from scratch. Survey your industry. See what knowledge graphs or standards you can adopt or borrow from. After all, graphs have been around for 30 years and lots of people have been out there doing some very wonderful modeling, and you can take advantage of that. Those models that are already out there probably use the domain language you need to communicate clearly with your audience. You can experiment, get people engaged, learn what works and what doesn't work. Find the barriers and the speed bumps that you're going to find either in your infrastructure or with your user base and figure out how to avoid or eliminate them. And finally, once you know what it is you really need, you can build out the technology base. Once you know what you're really trying to do and who you're really trying to serve, choosing the right technology base becomes somewhat easier, although you still have a lot of choice. In closing, a tool like Tom Sawyer Perspectives can be particularly helpful to explore what your real expectations are for end users and for others to interact with that knowledge graph before you make big new investments in infrastructure. With Tom Sawyer Software, you can experiment with the data you already have, ask important questions to inform your constituents, and to make really well-informed long-term technology choices. I hope you take a moment to visit our page on knowledge graphs, maybe take a look at some of our other use cases and explore how Tom Sawyer Perspectives might serve your needs in automated information layout for your knowledge graph. Thank you all very much for your time and attention and your interest in this subject. This was a very rapid overview of some very complex concepts. If you'd like to talk to us more about any of this, we have an open door. We'd love to talk to you. And we also offer evaluations of Tom Sawyer software if you want to experiment for yourself.